We'll read it and probably respond to it. Tonight there is a party. It's next door in the International Ballroom. You'll enter through the terrace level. It starts at 9 and you need your badge. So have fun with that responsibly. We have some wonderful sponsors here. One is Security University. Anybody like a free course with a few caveats? Enjoy. T-shirt? Anyone? Probably shouldn't throw those at the recording equipment. And then lastly, we have a software-defined radio from the Hacker Warehouse. So, if our tapers and streamers are ready, with no further ado, we have Scott Behrens and Andy Hornicke. Their talk is The Joy of Intelligent Proactive Security.
All right, thanks, guys. So we're here to talk about proactive security. And my name is Scott Behrens, and this is Andy Hornicke. It's kind of a brief introduction. I'm an application security engineer at Netflix. Before that, I worked at a consultancy out of Chicago called NeoHapsis, kind of responsible for doing a lot of application security, pen testing, and that sort of stuff. Also taught a security course at DePaul University, also on web application pen testing. I really like automation. I'm kind of torn between breaking and making, but I also love research and open source.
And I'm Andy Hornicke. I have a very similar background to Scott. I also spend most of my time doing AppSec. I also really enjoy Ruby on Rails development and data visualization.
So why are we here today? We're going to cover some of the challenges of a modern infrastructure, and I'm sure everybody here has kind of gone through that. You know, we're in a place now where some of the organizations we may work for kind of operate in an at-scale environment, or they're so agile that the traditional kind of security models just don't scale. And one of the ways that we're going to address that problem is really using proactive security as a solution, and we'll kind of talk about what we mean by proactive security. We'll also examine elements of a mature security program, like what are the steps that we would expect to see in a mature security program, and how could we potentially plug in some proactive security controls, open source tools, et cetera, to make things easier. We'll also talk about at the end how you can get started, and we'll also have a kind of a Q&A session at the end, so if you guys could just hold your questions to the end, we'll save some time if you want some further details. So it's kind of I just want to do like a little poll. How many people here work at a company that operates fully in the cloud, and public cloud? Okay. Partially in the cloud? How many people are AppSec engineers, either makers or breakers? Okay, good, cool. So as kind of a primer, we're just going to talk a little bit about the terminology we use at Netflix. And so when we say application, we really truly mean an application here. So when I say application, I'm talking about a service that I'm going to run. Instance is basically the platform that the application is going to run on. So you could potentially have an application that sits on an instance that ties into an auto-scaling group. An auto-scaling group is really a collection of instances. So you can almost think of that as like all of a sudden I'm getting a lot of load in my environment. I need to deploy more instances to potentially handle that load. An elastic load balancer is going to help us route the traffic between those instances. An AMI, what we mean by that is basically the platform. So the AMI is going to be bundled with our applications, and in the Netflix environment, it's immutable. So that helps us ensure that our base image is consistent across different applications, regardless of what the application is. Security groups you can kind of think of as like firewall rules. So that's basically how we configure what applications can talk to who. And regionals and availability zones are basically, you can kind of think of that as like literally exactly what it sounds like, different data centers provided by Amazon. And so in the event that like there's a catastrophe or we need to do like a sort of like a failover exercise, we have a place where we can do that. So just a little primer on Netflix. We have hundreds of developers and we have roughly over 1,000 applications. We have hundreds of production pushes a day. There's over 50,000 instances and there's no security gates. I mean, none. Besides SOX and PCI compliance, developers do not have to go through security audit. Developers have root on all their boxes. They can push code out into production without any sorts of gates at all. So you guys can kind of imagine that could be a little bit problematic, and that's one of the challenges we have to deal with. Another challenge we have to deal with is kind of continuous deployment. So this is sort of the idea that a developer can simply commit their code into Git and have it pushed straight out to production if they'd like. One of the ways we try to make that a little tighter is with this sort of immutable platform. So this helps us ensure that the underlying platform that the applications are run on are sound and secure. And Andy will talk a little bit more about that in the future here. What this kind of looks like is basically a developer could commit to Git. It's going to create a Debian package using Jenkins, which is kind of our build system. That Debian package is going to get baked into this immutable platform. So you can kind of think of this as like creating a template or a snapshot if you're from like the VMware world. And then that's ultimately going to get deployed out in the environment. So what are the potential pitfalls here? Well, one of the challenges we run into, and I would say this is probably the one that is the most troublesome and the one that we don't have a great grasp on yet, is multiple concurrent code bases. So one of the challenges we run into at Netflix is A/B testing as an example. So this is the concept that a certain subset of users are going to be potentially reaching a certain code path that other users aren't going to be hitting. We run into the same thing with regional functionality. Like we have Netflix.com, but it's different depending on where you're hitting it, depending on what region you're in. So that's sort of a challenge. We also have the problem of new applications being brought online and old ones are constantly getting retired. So we have this like churn of new things coming online and going down. And that's something we have to keep an eye on. Also, insecure third-party dependencies. I'm sure everybody here who works in AppSec has to deal with this. Like developers tend to roll a dependency into their application and it works. So why would I ever want to update it? So that's a challenge that we have to deal with. And there's even more pitfalls, like how do we actually identify and catalog what an asset is? Like in the modern infrastructure, is an asset simply an IP address? Or is it the DNS name? Is it the application? Or is it the ELB that's fronting that application? Or is it a combination of all those things? That's something we'll discuss a little bit later. How do we profile and provide baseline security to new applications? So when something does come online and we detect it, how do we ensure that at least it meets a baseline set of security requirements? As I mentioned earlier, developers don't have to go through any security gates, so how do we at least ensure that we're not putting something out there that's going to put us at risk? And then what about monitoring security policy changes and configurations in AWS? As I mentioned before, developers have free reign to do whatever they want, so they're more than welcome to create a security group that allows their application to be exposed on the internet with all the ports available, right? And that's something we don't want to see happen as a developer accidentally expose their internal development application to the web. And then what about like more incident response stuff, kind of like monitoring for credential dumps, hacktivism, people that want to perform denial of service against Netflix, sensitive data exposure. And I'm sure everybody here has probably seen a lot of these problems in their own organization, right? Like these problems aren't necessarily unique to the cloud. I mean, some of them are, but our opinion is that these can be solved in different ways. And we really coined our particular approach to these problems as proactive security. And so what I mean by proactive security is basically the dictionary.com definition I think is pretty good, is serving to prepare for, intervene in, or control an expected occurrence or situation, especially negative or difficult one, anticipatory. And I really think anticipatory is the key word here. We all know in security that like something bad is going to happen, so we should have systems and controls in place that can proactively anticipate what's going to happen, detect and respond in a timely fashion, and drive intelligence so we can get better at it over time. So we really truly believe that security controls should be integrated, automated, scalable, adaptive, actionable, and intelligent. And time is really limited. I'm sure everybody here also has to go through this. Like Andy and I are on the product and application security team at Netflix, which is 4 guys, but we're the only dedicated AppSec engineers. So there's 2 of us for over 1,200 applications. Right? So we don't have a ton of time to be doing manual pen tests of all these apps and stuff. So we really need to ensure that we spend a lot less time babysitting and putting out fires and more time engineering solutions for harder problems. So when I think about proactive security and I think about a mature security program, these are the kinds of things that I would expect somebody who has a mature security program would be able to say that they have these things in their program. I would expect them to be able to say that they could find problems early and address them, that they know what their weaknesses are, or know what some of their weaknesses are, and they're working to improve them. That they're monitoring for anomalies and they're prepared to respond. That they can collect meaningful data and actually use it. That they simplify and make security the easy path. They're able to reevaluate their approach when things don't work or when things break and their old solution stops working. And they share what they learn with others, like through open source, speaking at conferences and white papers and things like that. So when we think about finding problems early and addressing them, I think the old hat approach was kind of like the static asset list, right? Like, do you guys remember this? Like, you had the Excel file Like you added all your stuff in there. When things change, you like removed it, but like you don't, kind of maybe you missed something, maybe somebody forgot to update it. It's the same with the file share with the old pen test reports, right? Like I've worked at companies where, you know, there's like this file share and there's like maybe somebody created some JIRA tickets, maybe they didn't. You're not really sure like how you're doing over time, if you're getting better or worse. And we really think that's kind of like an old approach and it's really not scalable. So we think the first way to get better at this, and we think like the new hat kind of way, is to really first define what an asset is. And if you're operating in a cloud infrastructure, an asset is really a combination of different things. It's a combination of your application, your ELB that's fronting that application, potentially a fully qualified domain name, and your IP address if you're missing some of this stuff, like maybe you don't have an ELB in front of your app for some reason. And we also want to have an intelligent way to collect and track these assets. Like we should be able to know when things come online and turn off, right? We should also be able to perform vulnerability style scans against those assets. And the way we do that is with Monterey, which is this awesome logo. Monterey is our system that provides a way to automatically define and scan assets. It's also soon to be open source. We have an initiative to open source it this year. It's a Python application and it runs within AWS. So if you operate within AWS or you want to use it, you can deploy it out to AWS. So the way we kind of leverage Monterey is we basically create an asset group as an application name. So we have an application, maybe it's called billing, and it's going to have a series of ELBs or fully qualified domain names associated with it. We don't really need to couple in instances because, as we talked about earlier, instances are really immutable, right? They're identical. Every time I deploy an app, even if it has 50 instances, they should all be the same. What Monterey really does is it queries AWS for new assets and changes. So it's constantly polling AWS, and when things happen or when things change, Monterey can potentially do something like running a monklet. So a monklet is basically like a plugin. And you define a few methods in the plugin. So for example, we have a few monklets that do vulnerability scanning. We use Arachni, Zap, Nmap as an example. We have a g-evented web scraper, screenshotting, you name it. Basically, if you can write something in Python and make a wrapper for a tool, you can scale it and run it in Monterey. It also stores all the vulnerabilities centrally in S3. So let's do like a quick walkthrough of what this looks like. Cool. All right, so just a quick brief introduction here. I'm going to show a demo of Monterey, but keep in mind I'm doing all this manually. Monterey can be fully automated if you'd like, so we'll do it manually so you guys can kind of see how it works. All right, so the first thing I'm going to do here is basically take a look at some of the assets. So we're looking at parts of the asset groups here. I'm going to go ahead and try to narrow down. We see some ELBs listed here. I'm going to go ahead and narrow down www.netflix.com. That's the asset I'm going to want to do something with. So we can store a bunch of metadata with this asset, kind of your imagination if you need to. So I'll pause it here. The next thing we're going to kind of do is a configuration. You can think of a configuration basically as the scanner or the monklet, right? So we have Arachni, Threadfix, you know, a Qualys base AMI thing. I didn't write that, but that's in there. So you basically can just write these arbitrary plugins as long as you meet the specifications of Monterey. The next thing we're going to basically do is we're going to actually link some of these configurations together. We call this plans. So you can link any arbitrary number of scanners that you'd like to link together. So for example, one of the things we like doing is linking potentially Arachni and Threadfix. Threadfix is a platform that we sometimes use to kind of look at the results of our Arachni scans. So this particular plan is basically going to run an Arachni scan against the asset. It's going to upload those results automatically in the Threadfix. So the next thing I'm going to go ahead and do is take a look at the scans themselves. So the scan itself actually is a combination of assets or asset groups and the actual plan. So for example, we could potentially run this across n number of assets, and we can scale accordingly so that we can get the scan done in a particular expected set of time. So for example, if I need to run an Arachni scan against 1,200 endpoints and I don't want it to take months, I could scale up 150 instances to do it for me. So here we're just running against one, so we really don't need to scale to that size, but that is something you potentially could do with this system. So I'm going to go ahead and pick the asset or assets that I want to scan against. I'm going to go ahead and pick my plan. So we're going to do this Arachni and Threadfix combo here. I'm going to go ahead and save the plan. And the next thing I'm going to do is actually execute the plan. We can set this up to run on an interval, or we could set it up to run automatically as well. So the next area we wanted to focus in on was kind of monitoring. So this is the whole idea that we know that that things are going to happen, and we need to be able to detect and respond to those issues quickly. I think the old hat approach was really reactionary. You kind of waited until something bad happened, or you're constantly turning out fires. I've talked to security engineers where they're like, I wish I had more time to engineer this solution, but we're constantly putting out fires. We're constantly responding to stuff. And really, what we want to do is kind of shift the thinking to be a little less reactionary and more proactive. Really anticipate that this stuff's going to happen, and have an automatic and intelligent way to handle it. So one of the ways we did that is with the Simian Army. How many people have heard of this? Yeah. So the Simian Army is open source, all the monkeys are, and what they do is they proactively wreck your environment to simulate outages. So kind of imagine like you deploy an app and it's running, and all of a sudden your Chaos Monkey or Chaos Gorilla comes in and starts knocking down your applications. It crushes one of your instances. It takes down a few ELBs. You could even destroy an entire region if you want. What this really does is this allows us to ensure that if we look at the CIA model, our availability is really sound because it ensures that our developers write resilient code, right? If at any moment half of your instances could be wiped out, you need to make sure your application can handle that. The next thing I wanted to talk about was Dirty Laundry, which is a project that we've kind of started working on for looking for assets that are unintentionally exposed. And so what I mean by that is potentially maybe a developer, they screw something up in a build and they push something out, and maybe they left stack traces on, or maybe they've exposed some sensitive keys, or they didn't realize that what they deployed actually is on the internet. What Dirty Laundry does is allows us to get some visibility into that. This leverages Monterey for assets, as we've kind of talked about. Monterey is really our asset inventory. And we use Scumbler for actioning findings. Scumbler is a tool that we use kind of like a Swiss Army knife for a lot of things, and we'll go into some details on how we leverage that. We also use Sketchy, which is another open source tool for collecting status codes, generating screenshots and text scrapes, and both Sketchy and Scumbler are open source. So what Scumbler really is it is our Swiss Army knife. Andy kind of has been the lead developer on it, and he's been working on it, and like every 2 months we find another use case for it, so it's never going to end. So we'll constantly be adding stuff to it. But we use it to monitor things like credential dumps, hacktivism, and brand reputation. The way we do that is by writing plugins, once again. Things like search providers, like searching with Google, Pastebin, YouTube, eBay, you name it. We're even doing full disclosure. This is kind of a newer one where we're monitoring known third-party dependencies using RSS feeds from full disclosure as an example. The minute we get a hit that, hey, there's a new third-party dependency that has a vuln, we can go and investigate it really quickly. It also leverages Sketchy for screenshots and text scrapes, and it has customizable workflows, which really allow us to do more powerful kind of responses when we identify something, and we'll talk a little bit more about that shortly. So we'll go ahead and kind of do a demonstration of what Dirty Laundry looks like. I'm going to just go ahead and pause this here and kind of walk you guys through the initial view that we're looking at. So what we're looking at here is a series of endpoints that have been recently reported to from Monterey. The first endpoint here is new, so this is one that we haven't addressed, and that's what we'll be talking about during the demo. We also have some filters. So I'm actually filtering for endpoints that return to specific status code. I'm only looking at 200 and 300 XX, status codes. So the first thing that we're going to kind of do is we're going to take a look and see what this endpoint's all about. Is it something that we need to take a look at and see if it's interesting? So we can hover over to get a screenshot of what it is. We see a 403 bidden, so that could potentially be interesting. We also have a tile view here, so this is pretty nice. This actually will show you all the screenshots generated for all these assets. And you can kind of now get a visual representation. I like this view because if I'm looking and all of a sudden I see a stack trace, I'm like, okay, that's something that's probably a problem, right? So it gives you a nice visual view if you need to investigate further. So let's go ahead and take a look at this particular asset here. This should not be a 403 bidden. We shouldn't be exposing this. This is definitely something we want to address. So I'm going to go ahead and add a comment. And we'll go ahead and now set up a workflow for this particular application here. I also now moved its status into needs follow-up because this is something that I'm going to need to do something with. I'm going to use this workflow called information exposure. I go ahead and submit it. What actually happens in the back end is this is going to submit an email to this team. With workflows, you can pretty much define anything you want. A workflow could be a Jira ticket, an email, an SMS message, a combination of all three, a push out to some alerting system, you name it. You basically just define what you want those things to be, and you can roll them directly in the Scumbler. All right, so now that we've gone ahead and submitted our email, we'll go ahead and mark it that now it's under review. And we can now let the rest of the team that needs to respond to this handle the event. Another tool I want to talk about today is a tool called SpeedBump. This is our mechanism to detect attacks and enforce security policies automatically. And this is going to sound a lot like a WAF to you guys, so just bear with me as I explain this. So you kind of define what you want to monitor and filter, right? So maybe you're interested if a user repeatedly hits the same endpoint a certain number of times. Or maybe you want to be a little bit more savvy and you want to know if a user attempts to execute a direct object reference vulnerability or attempts to try to access somebody else's account, right? Those are kind of like application or business logic things, but we can actually potentially identify those and enforce security policies against users that do stuff like that. And those security policies could be things like time delays, blocking, routing, et cetera. So really what SpeedBump is it's kind of like a combination of a WAF, a proxy, and a firewall, but it's on steroids because it has business logic, right? Like we actually build it into the app layer. And Andy and I's opinion is that the app layer is the smartest place to roll this kind of functionality in because the app's going to be the most intimately, it's going to have the most knowledge of what's going on, right? And a lot of times, we think about the network layer, but really the app layer is where it's all happening. So I wanted to mention Ensnare. This is a project Andy and I open sourced last year. It's basically the Rails version of SpeedBump. So if anybody here is a Rails developer, and they like the idea of like a business logic style firewall, take a look at the Ensnare project. We'll have a link for it at the end. And if you have questions, talk to us afterwards. So another project I wanted to talk about is SecurityMonkey. This is also open source. And SecurityMonkey is really our Swiss Army knife of monitoring changes within AWS. So if a user all of a sudden starts changing their user roles, or they start opening up security groups to the internet, or they start changing policies, we can set up alerts to let us know when these things happen. And when the notifications happen, we can respond very quickly. So in the event that a developer logs in and opens up their application to the internet when they shouldn't, boom, we get hit with an alert and we can respond quickly. So you guys kind of noticed a trend here, right? Like all these tools that I've talked about, they almost all have the exact same steps in them, right? We basically identify something interesting automatically. We do some sort of notification or some sort of alert or some way for you to know that something's going on. And we provide a mechanism for you to handle the issue quickly using workflows. And the idea is that when you have a stack that executes this way, the amount of time you spend actually dealing with these issues is very, very small. And Andy's going to take over from here. So.
Thanks, Scott. So next I'd like to talk about the step of knowing, or in a security program, how do you know your weaknesses, know your environment, and work to improve them? So we really feel that this is one of the prerequisites to building a security program, is really having a good understanding of what's in your environment. And none of us have unlimited time. We're all constrained by time and resources. So it's really important to try to do this automatically and leverage tools where you can do so. Scott and I have worked at a lot of different companies, both as employees and as consultants, and we found that you'll be lucky to walk into a lot of companies and get a spreadsheet of the applications that they have that they're exposing to the internet or even using internally. So that's kind of the old hat solution that sometimes is in place, but not even always that. And that's not very scalable when you're talking about hundreds or thousands of applications. So we had to come up with something different. We wrote an application called Penguin Shortbread, and essentially what this helps us do is catalog all of our assets automatically, measure certain attributes about them, and calculate a risk value for us. We'd really like to open source this, but right now it's very reliant on a lot of Netflix-specific infrastructure, so we'll have to make it more generic first. So now I'll give a quick demo of Penguin Shortbread. All right, so this is kind of the main application view in Penguin Shortbread. It's really just a list of all of the applications that we have and which regions they're deployed in. But I can start typing here and I'll filter down to a specific application. There's lots of different reports in here that I could pull up, but I'm going to pull up this one application's detailed view and kind of take a look at that. And this is a billing application. So what's kind of interesting here is you'll notice there's a couple different components to this view. Up at the top, we have a couple different metrics that we're looking at to see how sensitive this application is. And these are set up dynamically based on what we feel is important, and I'll walk through that in a little bit. Down at the bottom, you'll see these sections with different information like how many instances does it have, what are its dependencies, what is it required by, the security groups it's part of, and then what's allowed to talk to it inbound and outbound. I could expand all these and I would get a detailed list of everything that's filterable and everything, but I'm not going to do that. And then in addition, over on the right, you can see that there's some other information like who's the owner and where would I email to contact someone who can help me out with this application if there's some type of a problem. And obviously, in addition, things like when was the last build job, where can I see it, where's the code on our internal code repository. So Penguin Shortbread really aggregates all this information for us so that it's in one place and really gives us a good way to kind of explore our different applications and see what's using what and how they interact together. So, so now I'm going to drill into or kind of show you some of the metric configuration here. So this is, sorry about that, this is a list of kind of the different metrics that we're looking at, and we're using these to risk rank these applications. And I can drill into one of them and kind of walk through this. Essentially, this is the dependent applications metric. And what we're using this, or how we're using this, is essentially for each application, we can determine what other applications are going to talk into or request data from it. And we're doing this based on some other Netflix open source software called Eureka and NIWS. So we can say that this billing application is being used by a certain number of other services. And what we've done is we've said, okay, based on how many dependencies that this application has, or dependent applications this application has, we're going to increase the risk value, because if that service goes down, it's going to have more of an impact to us, to our platform. So we've set up a few different risk levels here. These are all totally customizable. You could define whatever you wanted here. So if having 5 dependencies is a high risk, you could have that set up. The way that we have it is if you have over 100 dependencies for a given application, that's considered a very high sensitivity application in this metric value. But hopefully you can see that this is really very customizable. It gives us a lot of flexibility in risk ranking our applications and giving us a sense of what's really important to our environment, what is an important driver, what is absolutely critical to our continuing operation. And we can use this to essentially get lists of assets that we should look at first when we're looking at security. Where should we be spending our time, and what's most important to us? So another quick case study to walk through that we're calling Monklet Your Way to Infinity. Back when Shellshock came out, we really wanted to figure out which systems or which applications that we had out there were potentially exploitable. We knew that there were a lot of systems that were vulnerable since they weren't patched yet, but we wanted to know if there was anywhere that this could actually be exploited so that we could focus our effort on getting those fixed. We looked at some different commercial scanning tools as well as some other scripts that people had put out there, but we had a couple of issues. Number one, a lot of them only hit the root of the web page, which we didn't think was really sufficient to give you a sense of whether or not a given application was exploitable or could be exploited. And then the other problem with some of the other scripts was they weren't very scalable. So there wasn't a good way to scale these to be able to test hundreds or thousands of applications at a time. So what we ended up doing was we created a Monterey Monklet. And Scott walked through Monterey earlier and kind of showed how there's different configurations that can be set up and how it's really easy to associate a given type of scan with a lot of assets at once. So what we did is we created a Monklet that would go ahead and spider all of the applications and essentially check each and every page to see if there was a possible exploit for Shellshock on any of the pages within the application. And then we stored all the results centrally on S3 so that we could quickly review them. And what we were able to do is we were able to deploy a ton of instances of this Monklet so that we could very quickly scale up and scan hundreds of applications and get answers pretty much right away. So the next part of a mature security program that we want to talk about is collecting meaningful data and actually using it. And using it to improve. So we feel that it's really important to collect data from intelligent systems like some of the ones we've talked about, Penguin Shortbread and Monterey, and actually use it to drive initiatives that make your security better and find what is and is not working. So this is a dashboard from one of our tools called Scumbler, and there's really just a couple kind of interesting things to point out here. You can see at the top there's a results identified line graph that kind of shows how the number of our results have changed over time. And you'll see a couple of spikes there, right? So we've been able to correlate those back to specific events, and we can say that when something like this occurs, we know that we're going to see a certain increase in things like credential dumps or vulnerability discussions or social activist chatter around Netflix. So that's been really useful for us for planning for different types of events, kind of IR process type things. And then down at the bottom, we can see kind of a list of all of our different searches that we're doing, and they're blacked out, but you should be able to get a sense that we're essentially tracking for each of the searches that we're doing. We get kind of the total number of results we found, the number we found recently, and kind of a graph as far as the trending, right? So we can see if there's a certain search that is giving us a lot of results. Number one, we know that that's a good search if the results are good and we're able to action them. And number two, if that drops off, that's probably something we want to look at because we want to find out why something was effective before and suddenly it's not effective anymore. Has the site that we were searching, been abandoned by people who were posting interesting data there? Or, do we need to tweak our search terms or what do we need to do to, get that data and make sure that we're being effective? So next, I want to talk a little bit about simplifying security, making security the easy path. And there's really actually a couple things that we want to talk about here. Number one is making sure that security is easy for your developers. I think we know from working at a lot of different places that if security is the easy path, developers will do it. If it's not, if it's a challenge, if it makes their job a lot harder, they're probably going to blow past it and not take the time to do it. So it's really important to make sure that security enables development and doesn't prevent it. Additionally, we think it's very important to encourage developers to come to you with questions and concerns. And if you want that to happen, you can't be seen as a roadblock to them. You have to be seen as facilitating their work and helping them get their job done well. And then finally, as far as simplification, we think it's really important to remember that when you're engineering a solution, the first version doesn't have to be perfect. It's good enough to get something that gets you some results, and then you can always refine and improve on that in the future. So a couple examples of this. Scott mentioned really briefly the immutable base AMI. But basically, the way this works is within Netflix, when someone deploys a new application or a new version of an existing application, they're by default going to get an up-to-date version, blessed version of an operating system with all the stuff that they need already on it, and it's going to be up-to-date, fully patched, and ready to go. So this is really great because it means we don't need to be scanning all of these things constantly to make sure that people are applying their patches and things like that because they're automatically going to be getting them when they deploy a new version of their application. And we have a secondary control called Conformity Monkey that is kind of like a backstop for this and can be set up with certain rules so that we get alerts when something doesn't look right. So for example, if an application hasn't been deployed in a while and its base AMIs are getting out of date, we can get an alert on that so that we can work with the team to make sure they update their app. Another example of this is a project we call Danger. We know that as developers are creating applications, they're going to use third-party code and third-party libraries. That's a given. We also know that they're going to very quickly become out of date and potentially pose a risk to our environment because of vulnerabilities that have been identified. So we wanted a way to make it clear to developers that they're using something that could be dangerous. Right now, this is a work in progress. It's not where we want it to be yet, but currently what we have is an API where a developer can go, they can look at their application, and look at the dependencies in it, and they can get a sense of what vulnerabilities they're exposing by using those third-party dependencies, those third-party libraries. Eventually, what we would like this to be is more of a system where, as an application is developed, as it's built, developers and the security team will automatically get notifications if there's any vulnerabilities we might be interested in that would be introduced by using these third-party dependencies. And this is just kind of a quick look at kind of what the API output looks like now. You can pass in a library or a set of libraries and you'll get back the CVEs that are relevant and the vulnerability information. So this is one that we're definitely actively working on improving. Another tool that we're using is FindSec bugs, and I won't go into a lot of detail on this because I know you guys are probably familiar, or a lot of you are probably familiar with this. But essentially the way that we have this set up is we're allowing our developers to opt into static analysis for their projects. And this is very lightweight, and it's useful for finding some simple stuff in Java. We're not using this as a blocker, so it's not going to stop the deployment if it finds something, but we will make sure that we find out about it and the developers find out about it if there's some type of a vulnerability that FindBugs identifies. So the next step to a proactive security approach is reevaluate, and this I think is one of the most important ones. Especially somewhere like Netflix, the environment is always changing, and what's working today might not work at all tomorrow. Developers are agile, so we need to be too. And it's really important to be willing to scrap what you've been doing in the past and be willing to start over. Every solution that we build is temporary, so it's important not to over-engineer something. You know, if we wanted to build some type of a scanner like Monterey and it took us, 4 years to build a solution and get a version 1 out, that's not going to work for us. Pretty much all of the things that I've talked about, or Scott and I have talked about over the last hour, half an hour, have started as some type of a script on someone's laptop, and they've slowly been built up into something more robust, more scalable, with more features and a pretty UI. So it's really important to make sure that you start simple and you get some easy wins out of the way, and then when you find something is effective and useful, that you build upon that. Also, of course, make sure that you're using the data that you've collected to determine when something isn't working anymore. So we gave the example of Scumbler earlier. When your search results don't seem effective anymore, you need to revisit that and make sure you're finding out why. And then the last step that we really believe in is share what you've learned with others. So we feel like at Netflix, as well as a lot of other companies, we're all working on solving similar problems. And a lot of the tools that we've built several times in several different versions at previous companies, and essentially we've rolled what we've learned into each new version. But it'd be really great, I think, if more security organizations were sharing the tools that they develop, the information that they're learning with the community, so that it doesn't have to be a new discovery process every time you go to a new company or every time a new company is formed. We feel like this would prevent a lot of duplicate effort and really allow improvement on these security tools, since you'd have the entire collective consciousness of the security industry able to look at them and improve them. So this is the Netflix GitHub repository. There's at least 4 security tools up there now, and as we've mentioned, there's a lot more to come. So keep your eye out on that. We really welcome pull requests, issues, questions, discussion. So make sure that you provide us any feedback and get involved if you'd like. Just remember that we have a lot of things going on, so if it takes us a little time to get back to you, we will get back to you eventually, I promise. So really quickly, we wanted to walk through kind of, if you're starting from scratch and you're trying to build up this type of a program for your company, where would we recommend you start, and what kind of steps would we recommend you take? So the level 1, I think we've kind of alluded to, would be creating a list of assets and cataloging everything that you have, your applications, your IP addresses, your ELBs if you're in the cloud. It really depends on what specific types of assets you have. But creating a list of them and determining some way to rank them by severity. This could be a manual process at first, quite frankly, because you may have to just catalog these manually at first, but it's going to be a lot more efficient if you can automate this. So look for ways to do that for sure, and to automatically update and re-rank your assets as new things are created. So that's kind of the base prerequisite. Level 1 is get a list of your assets and rank them by sensitivity or risk. Level 2 is to start strategizing your security based on this information. So this is an example of how you might break it down, right? You're going to break your assets into a couple of different categories. Things that are really sensitive, so maybe your credit card processing, your PCI environment, anything that falls under SOX compliance. And those things you're going to want to examine extremely thoroughly. You might want to do a week-long pen test on that small subset of your applications. And then, so the second segment would be things that are used really frequently, right? So this is things like the base AMI that we've talked about, or third-party libraries that are used throughout your code in a lot of different applications. And those you're going to want to make sure that they're secure by default, that they're kept up to date, and you know, that you have things like configuration best practices documented, and that they're being looked at, and they're secure for your developers to use. And then, you know, the third might be everything else, and for that you'll want to find some good, decent baseline level of due diligence that you can apply to all of your other assets. And maybe that's a simple web application scan. You know, maybe that's a manual pen test, but it's very infrequently. Maybe it's having some type of a static analysis tool get roped in and getting alerts for really critical vulnerabilities. So there's a lot of different possibilities there, but it's important to kind of prioritize your time based on what's the most sensitive and what's, you know, what provides the most risk to your environment. So once you've done that, the next level would be identify weak links. So this is really doing a frank evaluation of your environment and saying, where are some of the things that could go wrong? What are some of our weaknesses, right? And there's a lot of different types of these. It might be architectural things like bad network segmentation. Maybe you're on a totally flat network. Well, that's good to know. It's good to document. And then you can put a plan in place to start to address that. Or otherwise, find other ways to mitigate that. It could be cultural, things like developers or maybe a specific team doesn't understand cross-site scripting. Well, once you know that, you can actually put in place a plan to remediate that by targeting specific training to those developers. So this is kind of the next level, is really determining how to measure your weaknesses, identify those weaknesses, and putting in plans, actionable plans to address and manage all of them. And then the fourth level is monitoring, alerting, and gathering more intel. So, you know, there's a lot of different aspects to this, things like detecting anomalies and security relevant functionality. So, you know, if you see a huge spike in password resets, that's something that you may want to evaluate. A huge spike in login successes or failures, same way. One of the things that we think is kind of important, dashboards are fun. We have a lot of them ourselves. We have a couple TVs up with some cool graphs and stuff. They're fun to look at. But intelligent alerting is much better, right? Because you don't want your team members having to look at this TV all day and watch for a spike. You want them to know instantly when it happens and give them something actionable to do with it. So it's really important to make sure that, you know, in addition to any dashboards you might have, that you also provide alerting when something is actionable. But only when something is actionable. You don't want, you know, to flood people's email with things that you can't do anything about. And Zane Lackey had a great presentation called Effective Approaches to Web Application Security. And one section of his talk was on some of the things they had done at Etsy around monitoring and alerting. And we would direct you to that because we think that was a really good presentation. And then kind of to wrap up, for all levels, always continually drive improvements into your tools, always be reevaluating and looking for ways to get a little more efficiency out of your processes. Be flexible and willing to adapt. Be willing to throw out some tool that you've developed for 6 months if it's not working anymore and start from scratch or find a way to improve it. And always share what you've learned and what you've been doing, because we would find it really useful. I'm sure a lot of people would find it useful. We had a couple of works cited here and then some tools that we included for your reference. A couple other notes. If you have any questions, feel free to reach out to us. This is our open source page for all of Netflix. There's a security section on there with the tools that we've outsourced from our team. We're hiring, so feel free to contact us. And with that, I think we'll take some questions. Yeah. Yeah.
It's interesting because you talk about like using cloud type architecture, and I'm trying to push like resource type architecture, and my current place of employment. And I'm wondering, do you designate separate servers, or do you cluster up, separate up the network such that there's like a production network and a production Netflix environment, and like you know, a separate environment for like staging your data? And how do you test that if you want to have like external testing available to you as well?
So the question was, do we segment out our network by test and prod, and then how do we test those different segments, essentially, correct? Yeah. Okay. Do you want to take that?
Yeah, sure. So yes, exactly. We have a test environment, we have a production environment, we also have an environment that's PCI blessed. So code kind of goes through all those environments. And typically the way that it kind of looks is during our deployment process, we have like a staging area. The staging is kind of the test. Information goes into there and then eventually makes it to production. The thing that's really interesting is that all the environments are identical. So when you're in test, you're in staging, you're in production, you're wherever, it's all the same. The platform, the application, everything is the same. So the idea is that if you test in any of those particular accounts or environments, you should have the same experience. Any other questions? Yes?
How are you being able to replicate the information that you would draw from an IDS in a cloud environment?
So the question was, how do you replicate the information of an IDS in a cloud environment? So Andy and I we don't work on we have a security operations team that really handles like kind of the more IDS stuff, but to my knowledge, we leverage, on the IDS stuff, we leverage Cloud Passage, which is a commercial product, I think, that provides some of that sort of functionality, and it's all aggregated centrally, so, yep. Any other questions?
Yeah, there's someone behind the light here.
For the difference, for some of the applications that you showed, the proactive tools that you developed, how much of that are you using Netflix, your own APIs versus kind of the native tools within the AWS environment? And are you also looking at things like Elastic Beanstalk and something you were using?
Sure. You wanna add on?
Yeah, so it's really a combination.
the question.
Oh, yeah, sorry. He was asking how many of the tools that we had shown during the presentation are leveraging Amazon's APIs and how many are leveraging, I guess, internal APIs, and then Elastic Beanstalk was a kind of add-on at the end. I haven't looked at Elastic Beanstalk, so I'm going to leave that part out, but it's kind of a combination. So for example, Penguin Shortbread relies on a combination of directly accessing AWS API and endpoints and internal network things like Asgard, which is an open source project. So it really kind of depends on the specific data that is needed. But yeah, definitely we have found that there is a need to kind of aggregate the AWS information, and it's very easy to go over AWS's like API limits when you're collecting this type of data. So it's good to have some source of aggregation so that you don't have to be constantly hitting AWS itself. But in general, that's kind of the source of truth as far as, what instances you have deployed, what ELBs you have, and all that different stuff. So it's really a combination, and it depends on the specific use case.
And I was just going to add one thing to that, too. We're also kind of going through the process of open sourcing more of these tools, and I think internally our decision is now is we're trying to make sure our design decisions are as Netflix agnostic as possible, and I think that's culturally too the way. So you'll see more Netflix tools coming out that are less coupled into the Netflix stack, so that users can embrace that stuff. It'll make it easier for us to open source too, so we don't have to maintain separate code branches and stuff. So that's something we're trying to work on. Any other questions? All right, thank you guys.